Hi there, welcome all of you. Welcome to this second lecture of Robotics and Controls. And today we are going to discuss Python plots and animation. So we'll see how we can use Python plots to visualize our data or the output of our programs, and we'll also see how we can use this plot function to animate the motion of our robots. So this will be really helpful in our future lectures because as we go on and write the dynamics of our robots, we want to visualize them in some way. So yeah, so before we start, let's just look at what we discussed in the last lecture. In the last lecture, we discussed basics of Python. So basically variables, data types, how list functions in Python, how lists behave in Python, the print statement. We also looked at conditional statements, if else and else if. We also looked at loops like while loops, for loops, etc. And at the end, we looked at functions, how to write uh, functions in Python, and um, like for example, we wrote a function about adding two numbers and printing them. We also looked at how matrix behave using the library NumPy. We initialized a matrix and did all sorts of operations on the matrix. Like we first saw how to multiply a vector with the matrix. We also saw how to take a transpose, inverse, and how to multiply two matrices. Uh, so this was done in Python basics. Let's now see. Uh, Let me just uh, let let us now see how to um, use Python plots. So let me make a new file name as Python plots.py, and let's start uh, programming in this. So first, let's start with very basic plots. Like we want to plot sine and cosine functions, let's say. So first we'll have to define a independent variable. Let's say it is t. We can also define it whichever way you want, but I'll start it with t. So we can decide like write it in form of a list or a kind of an array like this. Um, so what this does is so this is a function in NumPy which makes a list from 0 to 6 with 50 points in between, with the total length of 50 points. But for this we need to import the NumPy library. So NumPy as NP. Okay, now it's correct. So yeah, so we have imported. So let's just see what it will do. So print t. So yeah, let's just run this once. Yeah, so you can see it is an array of numbers from 0 to 6 with 50 points, overall 50 points in between. So overall it has 51 points, but it has 52 points, but between 0 and 6 there are 50 points. Okay, so yeah, so that's what t does. Now let's define our dependent variable. So for example, y1, let's say y1 is sine t. So you can see there is an error below sine function because there is Python does not have a sine function on its own. So NumPy has a sine function, so you can use np.sint. So what this does is it makes another list of y1 with each element being sine of the each element of t. Okay, so that's what this does. This statement does. Now let's plot it. So, so before starting the plot, Python does not have a plot function on its own. We'll have to import a library called matplotlib. do use plot function. So let's just import it. Import matplotlib, and in matplotlib the main function that we are going to use is pyplot, and we'll just import it as plt. Uh, so yeah, some of you might not have matplotlib installed in your PC, so you can, what you can do is just with your internet connection, you can use the command pip install matplotlib. So as soon as you make it enter, so I'm getting an error because I think I'm not connected to uh, so yeah, it's saying requirement already satisfied. So it is, for me it is showing this because I have already installed matplotlib. For you it will install matplotlib and then you can use it. So yeah, coming back to the code, so let's plot it using this. So the way we plot it is plt plot t comma y1, just this. Okay, so this is how we plot. Let's just run this code. Okay, I think the spelling of pyplot is wrong. Yeah, now it's correct. Now it should run. Okay, so something might have opened. Okay, so I think what's happening is it's closing. So I think nothing came up. I'll just see what happened. Okay, so plt dot bigger. This statement is required for just naming it, so that for example, if we have to open some other figure, another two plots at the same time, we'll have to give them names. Otherwise, if we don't write this statement, if we open some other plot, it will overwrite in that. So yeah, so this statement is necessary for that. Um, Now let's just run this again. Let's see what happens. Okay. Let me close this and pause it. Yeah, okay. So what was happening was the plot was popping up and closing instantly, and we were not able to see it. Now what we have done is um, this plot function plots the graph. Then we pause for 2 seconds. So this statement allows it to pause for 2 seconds, and then we close it. Close the Python function. So let's say if I uh, comment this out, what happens? Let's see. Yeah, so it pops up now. So it pops up and then it closes after some time. So maybe I think there is some default timer set in this. It may be different for you. It might not close, but yeah. So this is how it is. We can increase the duration for which it comes up. So let's say 5 seconds. Yeah, so it will stay on for 5 seconds and then close. Okay. So you can see that let's just put it for 10 seconds and let's just analyze the graph. So yeah, so you can see the plot is coming. It's a sine function from 0 to 6. So this is pretty much it. Let's now try to plot one another function cos. So np dot cos t um, will give you the function. Now we can plot it in the same figure itself, like in the same window. So like this plot dot plot plt dot plot t comma y2. Okay, now let's run it. Okay, so you can see it changed its color automatically because it's a second plot, so it changes the color. But still, there is no legend in this, so there is no way to identify which color is sine and which color is cosine. So what we can do is we can give it custom color and custom way it will show up. So for example, if we want to change the color, uh, red color, we want to change the color of the sine function, what we can do is just put it R. So this will make it red. So let's make the cosine blue. So these will change the color of the um, of the plots. There is one more thing. You can also change the style in which they are plotted. So right now they are being plotted using straight lines. You can also plot like dash dot. So this changes the style of the function. Let's see what these changes do. S- what these changes do. So yeah, so yeah, you can see. So the sine function came in red and the cos function came in blue and in dash dot line. But still, just by looking at the graph, you cannot say which one is sine and which one is cosine. So it's missing what is called legend, and also maybe x label, what is x, what is y. We can also do all those sorts of labeling. So how do we do that is let's add legend to uh, the graph. So basically it will give a box on the top of the plot which will tell which color and which line is which function. So we can write sine and cos. So what it does is so this will uh, this works in first come first serve basis. So the first plot will be shown as sine and the second one will be shown as cos. Okay. We can also label the x-axis and the y-axis. So the way we do it is we use x label function t and lt dot y label. Let's just call it y. Okay, and let's just call it y, and let's just run it once. So yeah, so you can see the red is one is sine, the blue dotted one is cosine, and it stays on for 10 seconds and then it closes. All right. You can also give a title to your plot. So let's say graph of sine and cosine functions. Okay. Now let's just run it. Yeah, so you can see the title graph of sine and cosine functions. There is a legend, there is x label, y label, and you have changed the way you want to plot. So in this way you can plot any function. Uh, so yeah, so we also saw that this everything is in one window. So this happens because we we wrote this statement plot figure 1. Let's try to plot in some other window, figure 2. And what we want to do is, let's say, we want something like tan function. So np dot tan t. Okay. So we want to print that. Just let's just copy this. Let's make it green this time and by 3. So this statement will plot tan function with green color and dash dotted line in figure 2. So it will open a new window. We can give legend also. So basically, though there is only one graph, let's just give some legend, and yeah, that's it. So let's pause it uh, for 10 seconds and close it. Okay. So what this code will do is it will open first window, plot the sine and cosine function, show it us for 10 seconds, then close that window, opens new figure and show the tan function, show it for 10 seconds and then it will close it again. So let's see what it does. Does it behave like it's supposed to or not? So yeah, so this is the sine and cosine function. It comes up. Closes and then tan function. So you can see tan function is green and dash dotted, and these lines in between are drawn because it tan becomes goes to infinity at some particular point. So because we have discrete points, it was plotted like that. So yeah, so this is how things are plotted in the in Python. You can use it to visualize your graphs, visualize your data, etc. Now we'll move on and see how we can animate some of the stuff or like animate using plots. Yeah, so now let's start with some doing some animation. So first we'll create a new file named animation.py. We'll write our code here. So again, so as I said, for animation we'll use plots. So for animation, think of your animation in Python as a flipbook. So what happens in a flipbook? So there are several number of freezed frames, and they are shown you one after the other very fast, uh, and it feels like it is an animation or a movie. So a flip up. So think of your animation in Python as a flipbook. So what we'll do is we'll plot one frame of our animation. Then we'll uh, with a very less time we'll plot the second frame, and then so on and so forth, and it will feel like it is being animated. So yeah, so let's start. So what we are going to animate as an initial example is we have a sine or cosine function, and we want a small circular bead moving through it, as if sine function or cosine function is a thread and a circular bead is moving through it. So let's try to animate this. So because we want to plot a sine and cosine function, most of the code will remain the same. So import numpy as np. We also want to import matplotlib dot pyplot as plt. Now let's define our independent variable like last time, np dot linspace 0 comma 6 comma, let's say we have 100 points in between 0 and 6 this time, and okay, let's keep it 50. We'll see how if we change this number what happens. So now y equals np dot sine t. So so far same as the previous code. Now let's open our figure. So fig figure gre 1. We open the figure window and let's plot it. Plot dot dot plot t comma y comma, we want it in red, so red. So let's just run this code first and see if it is working properly. Again the same thing. So it will have to pause for some time. pause for let's say 5 seconds and plt dot close. Okay. So it works properly. We got a sine function in red and then it pauses for 5 seconds and then it closes. Now let's plot a green bead. So plot let's say plt dot plot. Uh, so let's plot it at the initial point. So t 0. So index in Python starts with 0 to t0 y 0, and we want, let's say we want it in green, and yeah, so we want it in green, and the way we want to be shown is dash and round. Okay, let's try to plot this and see what happens. So this is basically it will show something in round in a green color at the initial point of the graph. Okay, it will pause for 5 seconds and then it will close. So let's run it. So yeah, you can see there is a green bead at the initial point and then it closes. So what we need to do is we have to uh, move it over the sign in successive frames. So this can be done using loops. All right. So let's try to make use of loops. Okay. So yeah, and so what this is doing is it's taking an I and range from length to t. So we saw how loops work. So length to length t function gives the length of the list t. Basically, it will give it 52. And then I is from 0 to, it runs from 0 to 52 or 51, whatever. So so it moves from 0 to the length of the t. So this is what for loop, and we want to, at each instant we want to plot ti yi. So basically the point on the graph. So now let's plot this. Okay, so what it does was because we didn't pause it, it plotted um, in one go and we couldn't see it. So let's pause it for some time. Let's say plt pause it for 0.02 seconds. Let's say we plot it for 0.02 seconds. Now let's run it. Okay. So you saw the animation. Yeah, but the thing is, it animated it properly, but uh, we want the previous beat to be removed. So we want the beat to move through the um, beat to move through the thread of the sine function and not plot it like this as it has happened. So we want a single beat to move through the whole sine functions thread. So what we can do is we can remove the previous plot as happens in flipbook. So flipbook, the previous frame goes out of sight and the new frame comes. So for that, to remove it, we can create a temporary name for this plot. So basically this is the plot of beat. So let me just comment beat, and we gave it a name tmp, and we'll remove tmp. So tmp dot remove. So what happens is it plots this bead, it waits for 0.02 seconds, it removes it and then moves on. So let's see what happens now. Yeah, so it behaved in a way that we wanted it to behave. It's just that at the end there was a 5 second extra pause that we can reduce now to 1 second, let's say, and then we'll close. So now let's run it and see. Yeah, so it now closed in 1 second, and um, you can see it was kind of animation, though it was too fast. What we can do is maybe let's reduce this the pause time. I think it will make it much more faster. Let's see. Yeah, so it made it more fast, I guess. Let's slow it down. I change the pause value to 0.05 seconds. So it made it slow. You can see. Yeah. Now let's see what changes if we change the number of points in between from 50 to 100. Let's say there are more number of points, so it will become slow. It should become slow. Let's see what happens. So yeah, now there are 100 points in between, so it becomes more smoother, but it is slower as compared to 50 points in between. So this is so generally how you can do animations. Animations, but you can see there is no physics. It's just moving according to a function. There is no physics involved because we haven't included any physics in our equations. So now let's do an animation in which some physics is involved. So we want to understand a simple harmonic motion in which some physics involved, and let's try to animate that.